Hello everyone. Today what we are going to do, we have to analyze this component by creating mid surface and then allocating thickness and material with property to study the behavior after applying 1000 Newton load. So what we are going to do, first we have to create the mid surface of this component. For this purpose we have to go to geometry, create mid surface, then auto. Whenever you have a solid body, for creating a mid surface you have to select solid between this. If you create surface, then there are several components which were created within the component, so you have to be sure that you have selected solid over here with auto extraction. Click over here, then select display. This selects the whole component within the graphic window. Then click on extract. After clicking on extract, the component create mid surface, which you can see by hiding other component which were shown within the component. So over here you can see that the mid surface was created, but there are yellow edges which should be converted in green edges or be joined. You can see that after creating the mid surface, it was clearly visible that the mid part was not joined with the corner surface. For this, what we are going to do, we have to extend this surface to the next first surface. Before that, what I am going to do, I am going to rotate this surface through 90 degree with respect to this surface. For that, what we are going to do, we have to create a rotation node. For this purpose, we have to click to geometry, then click on node, select extract on line command, then click this line or edge over here, then the number of nodes should be 1, then create click. After creating on click, you can see that there are node created over here. Now what we are going to do, we have to rotate this surface with respect to this. For this purpose, what we are going to do, we have to go to geometry, rotate and surface. Over here we have to select the surface which we need to rotate, then click over here, then you have to tell the nodes around which the node is going to be rotated. So for this purpose, select first node, sorry, it was not selected properly. Again I am going to geometry, rotate, surface. For better selection, I am going to zoom the component and click on surface, then click on first node. For this I am click over here, second node, third node. If somehow your graphic windows doesn't show these nodes, so you have to display fixed points. For rotation point, what we are going to do, we have to click over here, then by 90 degree we are going to rotate this component. So you can see that the surface is going to be rotated by 90 degree. After this, what we are going to do, we have to extend the surface to the end boundaries. So for this purpose, I am going to geometry, edit, surface, and then click on extend. After clicking over there, you have to select extend over the edges and two surfaces. Then what you have to do, you have to select the edges by clicking over here. So this edge, this edge, this edge, this edge. Be sure that you have selected all the edges which you need to extend to the next surface. Then surface to extend, so we need to extend this surface to what is the target, so we have to click over here. So now click on extend. So you can see that the surface was extended and joined with the first surface which we interface. Same thing was to done with over here also. So click on this edge, this edge, and be sure that all edges are connected. Now there is one more edge which we can see over here. So click over here and then surface to extend, surface target, click over here and then extend. So the mid surface was cleanly joined with the coming surface. Now you can see that there is a red edge between two nodes. We have to remove this thing. So for this purpose we have to create geometry, edit, surface and trim with planes and surface. With the help of this tool we can remove or join these two nodes, and click on surface, select two intersecting surface, so click over here and select this surface. Now trim. As we have created all the yellow edges, after this what we are going to do, we have to define thickness with respect to the component we have created. Before that we have to remove excess surface which was created over here. For this purpose we have to go to tools, delete, select surface over here and then delete entity. With respect to the original geometry what we have over here, this geometry is of 10 millimeter thickness. This is this middle part and this middle part. You can see by showing one by one. This part is of 10 millimeter thickness, and over here this is of 8 millimeter and this of 6 millimeter. For this purpose, for incorporating the thickness within the mid surface, what we are going to do, we have to create several components. Before that what we have to do, we have to create material for the purpose. So we are selecting steel is over here, so and select the material properties, new and density of material. After this we have to create property. Before that I am going to create components, so it is clearly that how many properties which we have created to assign the thickness. So for that purpose I am going to create 3 components with respect to 10 thickness, 8 mm thickness, and third component is 6 mm thickness. For that purpose we have to create property also, so which should be T10 10 mm thickness property. Create another property for 8 mm, T8, and then T6 property. Assign all the 3 properties of steel, so that for you have to click over here, select material steel and click OK. So steel material was assigned to all the 3 properties. After this you have to tell the software that what is the thickness of each property. So when you are clicking over here, you have to try 10 mm thickness, 8 mm, and this is of 6 mm. Now you have to assign all these properties to the component which we created over here. So for 10 mm component we have to assign 10 mm thickness, 8 mm thickness we have to specify 8 mm thickness property, and same thing was to be done with the respect to 6 mm thickness component. After this what we are going to do, we have to create a 1D element for assigning the constraint and load. So for this purpose I am going to mesh. Before that I am going to create a component rigid body element, that is called RGB. Now we have to create a 1D element, that is rigid body. Actually it should be RBG, rigid body element. Then before that we have to alter mesh for assigning the these component. So we have to do an auto mesh with respect to 2D. Now we have to create meshing on the component. For this purpose we have to take auto mesh element and select 5 number of element, select all the surfaces which was showed in the graphic window, then mesh. If you want to change the number of element over the circular component, you can change the size of the element size and then click on recalculate, then again click on mesh. So you can see that the number of element can be increased or decreased with the help of this tool. Now with the help of mesh style, if we want to change all the component, all the mesh element with respect to a certain type, then click on set surface. So this icon will be activated. Then select the surface over which you want to create all the elements should be such type. Then set all and then mesh. So you can see that over on this surface all the elements should be of quad type. So with the help of this tool you can create such things. Now we have to assign all the element which created all the thickness component to this mid surface. For this purpose what we are going to do, we have to go to tools, organize, select first element, or you can also use select by surface. So this part and this part is of 10 mm thickness. So be sure that all components are selected correctly, then move. So after assigning the color should be changed. Now this component is of 8 mm thickness. So select the single element and then click on by face. Be sure that all the faces are selected. Then this should be T8, then T8. Now the last surface which was remaining is of 6 mm thickness. So click on by face tool and check all surfaces are selected or not. So over here there is one surface left, so click again on by face, so it was selected. Then it is of 6 mm thickness, then move. So all the elements are, all the surfaces assigned with thickness component which we created over here. After this what we have to do, we have to apply constraint and load. For this purpose, if we want to assign singly a certain load over here, for this purpose we are going to create a rigid body element. For this purpose I am going to rename this. This is called a rigid body element. So this is called rigid body element. Then you have to go to mesh, create 1D element and rigid. Okay, so for this purpose we have to click this over here with multiple nodes, and this should be in calculate mode. With the help of shift key you can click over here and you have to change the selection method. So we have take a circular component, and with the help of shift you have to use mouse left button for selecting the nodes. So over here this one, this nodes, these nodes and these nodes. So all this will be connected with a single point in such a manner. I am going to change the color after this. Same thing will be done for these also. Separately. So for this purpose I am going to create a circle by pressing shift, then click create. Then you have to perform this step for all the 4 nodes or 4 centers. And click shift, then create, then again this and create. Now we created a rigid polygon for all the circles. Now we have to create the load collector. Now we have to apply constraint and load. For this purpose we have to create load collector with respect to constraint, single point constraint, and there one more load collector. It should be force. So B shows that the SPC is should be make current of in bold for applying the constraint which we are going to apply. So for this we have to apply constraint over these center rigid poly elements. For this you have to go to boundary condition, create, and then constraint. Select the center node of each rigid body element as you selected. So these are first three provide constraint with respect to linear direction, and these three provide constraint to rotational motion with respect to the linear direction. This is the relative size of the icon showing over here. Load type should be single point constraint, and click create. Now again we have to create force. So be sure to make current this load collector and go to boundary condition, create force. Now you have to select this node and the magnitude should be 1000 Newton, and for direction purpose what I am going to do, I am going to select two nodes over here for direction purpose, one node and second node, then click over create. So the force component was created. Now what we have to do, we have to create a load step which joins the or select the solver type method. For this I am going to the subtype, or we can step to load step, then click. The analysis type should be linear static, and in SPC you have to select the SPC component which we created over here, and then select load with respect to force. Then we almost created all the necessary component with this to perform our analysis. Now what we are going to do, we have to go to analysis, and then we have to click on Optistrut, select run option as analysis, and then click on analysis Optistrut. Now there is a pop-up window shows which shows that our result is completed. For seeing the result we have to click over here, or we can open the hyperview to check the result of the deformation which was created over here. So after this we can see the result which was generated after applying the constraint and load over the component by creating mid surface. So we have to just wait, it will come in a moment. Now click on apply. So with respect to the contour, that what amount of deformation was happened with respect to the component after applying the load. You can check over here deform, click on displacement, or so apply. So we have to take the value over here with respect to 300, then unit. So this was the component deformation with respect to the, we can choose over here component to compare that what amount of deformation was there. This was deformed in XYZ direction, or you can create a uniform value for applying the. If you want to check the stresses, you have to create contours with respect to displacement component and then apply. So this was the deformation which was created with respect to the magnitude when comparing to displacement. With respect to the stresses, you have to change to 2D element or 3D element with respect to element stresses, and then click over here. You can create two windows for seeing both results at a certain time. Then for this purpose you have to click over here active model, copy, then click over here active model, paste. So with the help of two windows you can change the or compare both results at a time. So with the help of two windows you can see the displacement and element stresses in a single step. You can also make compare. You can also publish this result in a PowerPoint manner. So with respect to publish PowerPoint, so with the help of this method you can create PowerPoint images of the result. Till this time I haven't installed that software right now. So with respect to legends, if you want to change the value, so you can also select simple averaging method to apply this. Also in the legend you have to edit legend, then it should be in fixed, or the decimal number position should be 1. After applying you can see that the legend was simplified manner. You can do the same thing in the first window also. One more thing, if you want to change the value of any kind, first we have to click on this screen and then edit legend. It should be fixed type, and then the precision value should be 1, then apply, then OK. It is very small value, so we can't do such things, or we have to take to 2 value, apply, apply. So these are different methods with the help of which you can see the result. After this, so this, by in such a way you can create mid surface of a component. With the help of rigid body element you can apply load and constraint to study the analysis of a component.